Welcome to the 1999 Lucent Technologies Patent Recognition Ceremony. Your host for this event is John Dixon, Group President of Microelectronics Group and President of the Intellectual Property Business.
Well, good afternoon to you all, and welcome to Lucent's annual Patent Recognition Ceremony. It is really a great pleasure to be here with you and to recognize your accomplishments. The creation of intellectual property is the lifeblood of this company, and since the beginning of this program 9 years ago, we have honored over 250 inventors of more than 100 patents, and today we will honor another 24. I'm very glad, and I think this is a major step forward in this event this year, to see so many of our officers and executives who are here with me to recognize your achievements. We'll be hearing from Dan Stanzione, who's our President and Chief Operating Officer of Lucent Technologies and President of Bell Labs and of the broadband networking business. And Dan is here with us to honor the 24 inventors and the 6 patent attorneys who have contributed so significantly to Lucent's commercial success. I encourage you to sit back and enjoy yourselves this afternoon, and for those of you who would like to take any pictures, I'd appreciate it if you would limit that to when the inventors are actually on the stage. Our theme today, Innovation, the Key to Success, could not be more fitting for this corporation. There's nothing more basic for Lucent's continued growth than its invention and innovation. The commercially significant patents we celebrate today, and the inventors and the patent attorneys responsible for them, provide the foundation for that innovation that sustains our growth. As we look at the 7 inventions being honored, you will recognize technologies that are a fundamental part of the fabric of the world's data and telecommunications networks, all the way from voice messaging through to optical fiber. We have all benefited from the inventive expertise of our honorees. Lucent's future competitive success will depend heavily on the ongoing production, implementation, and commercialization of intellectual property. Patents are vital to our sustained business success in a brutally competitive marketplace. Since the launch of Lucent, we have significantly stepped up the pace, clearly pursuing the creation and utilization of our intellectual property with tremendous vigor. Your creativity is exhibited in the patents we recognize today, and I encourage all of you to continue this pursuit and to do it even faster and even better than before. You are contributing in a uniquely valuable way to Lucent's continuing growth. Innovation is the key to our success, and strong patents developed by creative people will maintain that success as Lucent leads the networking revolution into the next century. Today's program is intended to say thank you by acknowledging the importance of you, our honorees, to our success in the worldwide marketplace. We'll begin our ceremony today with a keynote address from Dan Stanzione, followed by the presentation of the awards. Each award will be preceded by a video highlighting the invention. But first, ladies and gentlemen, it is my pleasure to introduce the recipients of the Lucent Technologies 1999 Patent Recognition Awards.
Innovation, the key to success. Innovation, the key to our future. At Lucent Technologies, today and every day, we invent our future. Each innovation moves us one step forward. Today's innovations are the framework on which we will build tomorrow's technological dreams and the next day's technological realities. Our inventors and scientists, and all of the people who make these dreams come true, working together to move us forward into the next millennium. These people, through their hard work and undying curiosity, affect our daily lives in ways we can't even begin to realize. People whose inventions reach out like a great technological web, touching us, bringing us together. The discoveries of the great ones, Aristotle, Copernicus, Galileo, Columbus, even as they defined their ages, wouldn't have been possible if not for technology like the sundial, the pendulum, the mechanical clock, and the compass. Devices invented and perfected over the centuries, more often than not, communal achievements. Those responsible for some of the most sweeping changes in human history are often forgotten, just as incremental inventions throughout history have left few records. Speech, language, writing, the wheel and the sail, the stirrup and the plow, all mark epochs in the rise of civilization, all invented anonymously over ill-defined millennia. While the names seem far less important than their inventions, far-reaching is the impact they have had on our lives. We are content in the knowledge that their incredible discoveries have enriched our journey through life. We humbly accept the gifts of these nameless inventors and pass them on to our children. Before this ceremony is over, you will have a clear picture of those who continue to touch all of us and how their ideas will propel us into the future. They are among us, individuals like those early innovators whose gifts were often accepted without thanks or appreciation. They stand on the shoulders of giants such as Bell, Edison, and Einstein. It is with great pride that we take a moment to see that these individuals are not forgotten and are given their proper honor. These special people, who carry on in the tradition begun by one of the world's greatest inventors, Alexander Graham Bell, who once said, "Inventors can no more help inventing than they can help thinking or breathing." Now let's take a moment to meet the inventors we're here to honor tonight. The 1999 Lucent Patent Recognition honorees are Albert Ballman, Rolf Berkey, Peter Costello, Robert DeAnda, Lawrence Fawcett, Arthur Hart, Richard Huff, William Jones, Wayne Calvo, Gary Kepley, Michael Lane, Eric Larson, Robert Laudis, John Lothrop, Elizabeth Mazer, Albert Mizrahi, Vikram Punj, Terrence Quinn, David Rudd, Nicholas Smith, Ronald Spanky, Nancy Stevens, Mark Strauss, and Kenneth Walker.
Good afternoon, everyone. It is really a pleasure to be here with you. I think one of the best parts of my job is to be able to interact almost every day with really creative, innovative people who are making a difference in the marketplace. And there's probably no better occasion than this one to have that experience. So it's really fun to be here with you as well. Also on a beautiful spring day when nature is exercising its creativity to the utmost as well. So kind of a perfect day for it. And as you may know, the intellectual property business always schedules this patent recognition ceremony at an auspicious time of the month. And this year it's certainly no exception. In fact, this year I feel a great sense of personal significance. Mike Green, I guess I can thank you for this. Since May is Older Americans Month. And I'm also grateful, though, that this week, this is true, I'm not making this up, is National Historic Preservation Week. Actually, the whole month is really a smorgasbord kind of month. It's National Barbecue Month, it's National Egg Month, and it's National Hamburger Month. And after all that cholesterol, it's also National High Blood Pressure Education Month. In a more recuperative way, it's also, this is true, National Salsa Month and National Salad Month as well. And so I know you're now all built up in a real frenzy of chronological significance, so I'll conclude with telling you, at least in this chronology, that today, this very day, is the annual Preakness Frog Hop. And in the Preakness Frog Hop, it turns out that the first place frog, not the owner, but the frog, is flown to compete in the Calaveras County Frog Jumping Jubilee, and kind of in memory of Mark Twain. So starting tomorrow, you can't make this stuff up. Starting tomorrow, this unchaperoned frog will compete with 3,000 other frogs in what's called the Super Bowl of frog jumping. And it just doesn't get any better than this, I'll tell you. So all that is a lead into a Super Bowl of creativity. And we have that here today. We're recognizing some very special inventors and patent attorneys. And frankly, just as we celebrate their truly significant inventions that they've worked on together, we're really recognizing their families and guests who are here as well, whose contributions, while different, are just as significant in contributing to Lucent's success. I thank each of you for being here. Collectively, the inventions that we celebrate now have really made a difference in the way we work and the way each of us plays as well. And from the Lucent business perspective, they have generated hundreds and hundreds of millions of dollars, in some cases billions of dollars in revenues. Today, on a very special occasion, we also honor, in this Super Bowl of creativity and inventors, we also honor the memory of a real Bell Labs superstar, and that's Robert Lodice, who passed away this past year. His invention of synthetic quartz growth contributed to the key science for the spawning of new materials. And this patent underlies commercially grown hydrothermal quartz crystals that are used for frequency filters in telephony, as well as for timing elements in things as simple and straightforward and common as watches, and the clocks for computers and other electronic devices. The estimated value of that market to which Bob contributed is close to $3 billion annually. So kind of special for that reason as well. The theme, as you've seen, for today's ceremony could not be more appropriate. It's innovation, the key to success. And because inventions are really the foundation and really the beginning of the innovation process, this team sport of speeding new technology to the marketplace makes it a very appropriate theme. As certainly many of you know, we're doing an excellent job in the marketplace, and while that's a day-to-day battle, the recent quarterly results demonstrate the success. Let me review briefly for you how Lucent is doing in the marketplace. If we exclude the one-time events, as we always like to do, net income more than doubled over the quarter of a year ago to something over $450 million, or 17 cents a share, and that was a couple of cents above Wall Street expectations. Revenues increased quarter over quarter an incredible 33% over a year ago, and that was just over $8.2 billion. The revenue increase is really significant. We increased our revenues in the United States by 24%, and we saw just continued strong sales growth outside the United States, growing revenues by over 60% compared to the period of a year ago. And frankly, this is if I recall correctly, the third straight quarter where we've grown revenues outside the U.S. over the previous quarter, the previous quarter, by over 40%. So robust growths across all regions, even including the Asia-Pacific region, where, of course, they've got softness as a result of the economic conditions there. So we're gaining share around the world. All told, the Lucent business to which these inventions and inventors have contributed, and of course many, many thousands of employees around the world, all told we're on track to increase in revenues this year by around 19 to 20% for our fiscal year, which ends September 30th. And we have told Wall Street it's our goal to increase earnings per share by about 35% year over year. These financial results really come from exploiting opportunities and really exploiting innovation and the creativity, much as the inventors here have allowed us to. And the results grow out of unprecedented demand for network capacity among both established and emerging service providers, the accelerated build-out of next-generation networks, and of course, thriving commercial enterprises, and then the feeding of those with components and systems throughout throughout the world from Lucent Technologies. So what's going on in this global marketplace, and why is it such an exciting time for us to be participating in this extraordinary communications revolution? The revolution is really being driven by a number of things, and probably the most significant is burgeoning customer demand, primary market demand, and of course by technology. And these two things interplaying with each other in a way that's unprecedented in the history of our industry. And changing, and of course an overall change in the dynamics of the marketplace. So all three of those things occurring at the same time. Extraordinary technology, which I'd like to talk about, the primary market demand, which is also extraordinary, and then dynamics in the marketplace driven by competition and liberalization around the world that are driving forces affecting what's going on in our communications market. The real story probably begins with this primary market demand and really makes it a wonderful time, frankly, for us to be in the industry that we're in. It is truly unprecedented customer demand. Let me try and illustrate that with some numbers. It really took, the reference in the tape was to Alexander Graham Bell over 125 years ago, and in the first 125 years, around the world, 700 million telephone lines were installed. The most conservative estimate is in the next 20 years, that same number will be installed again. Just over the last month, John Dixon was in China. At a different time, I was in China. When I was there, I had some time with the Minister of Communications. In that country alone, last year, they installed 23 million telephone lines. 23 million in one, that would be like installing the equivalent of a Bell South in 1 year, in one country. So just in basic telephony alone, about 30 million telephone lines going in a year. And if there is a magic number in communications, it probably is this 30 million, because on top of 30 million new telephone lines going in each year, there are about 30 million new wireless subscribers coming onto new wireless networks and existing in new wireless networks around the world. And the estimates there, frankly, for last year are well over 30 million. So in each of these cases, it's not a projection of what's going to happen in the future, it's what's happening right now. And on top of this, as if that weren't enough, there's of course what I think is the most interesting phenomenon of all, and that's the internet. And the internet itself is also adding about 30 million users a year. But on top of that, from a networking perspective, exhibiting much different traffic characteristics to what we're used to in telephony, and frankly, changing the way we think about communications. It's changing the way we think about communicating with each other. It's changing the way we think about communicating in terms of commerce, and I think we'll have even more profound changes as we go forward. All three of those things make for unprecedented primary market demand and unprecedented opportunity, and frankly, a lot of that is being fed by extraordinary changes in technology as well. So in technology, there are a number of changes going on, and I think many of us in this room, of course, have a special interest in technology, and there are really, in my view, 5 key technologies that are helping to feed this change in the marketplace and helping to feed this extraordinary primary market demand that we're seeing. And the 5 are silicon, optics, wireless, this change from circuit switching to packet and cell switching, and then software for both new services and network management. I think most of you are familiar with what is called Moore's Law. It's rather well known. John Dixon lives his life in Moore's Law, and that really has accounted for the covering of the globe in silicon and the rapid changes in performance and capability that we continue to see after now 3 decades of progress in integrated circuits. And in short, what that means for those of you that may not be familiar with it is that each year we add as much capacity and performance in silicon as in the whole previous history of the industry. So every year we add about the capacity of the whole previous history because of this doubling effect every year to year and a half. While that's a fairly well-known phenomenon, what's not as well known is that the characteristics that are going on in optical transport, transmission of signals over fiber, and in wireless are having exactly the same kind of performance capacity growth, doubling at the rate of every year or so, more and more capacity in the network. On top of that, there's this fundamental shift from circuit switching to packet and cell switching, and on top of that, new software for services and helping operators lower the cost of their networks and helping those in an enterprise offer new services and lower their cost of operations as well. So all of this coming together to make an extraordinary time in our industry. Burgeoning demand, new technology to help make it grow even faster, and a wonderful time for Lucent in what we're doing. And again, the internet changing how we think about networks in general. The internet is a critical, very important piece that's really changing how we think about networks in many, many ways. I read a piece recently, as I recall it was in the Financial Times, where the author said how often we underestimate the profundity and overestimate the immediacy of change. That we predict that it's going to be happening tomorrow, and it really takes a little longer than just tomorrow. But in the end, in many cases, the technological change, the market change, and the societal change is actually more profound than any of us could have thought in the first place. The internet is probably like that, but maybe we are not underestimating the immediacy. We're having the change in networking come across so quickly. But there's more to what's going on in networking than just the internet. And so Lucent's view of networking is really much broader than this extraordinary phenomena we call the network, we call the internet, but really a vast network of networks that are coming into place. The networks that are certainly already existing in many businesses, the networks that are really beginning to show up on homes and across, and of course, the public networks that interconnect these networks. We in Lucent are really trying to do three things in the world of networks. One is to really lead in the definition of and the building of next-generation networks. Secondly, to help those that have existing networks, either a service provider or a large business, transition to these new technologies. And perhaps most importantly, to operate in the space between the networks so that the billion users each day that use the internet, about something over 100 million there, 100 to 130 million there, the 700 million that make phone calls every day, and the 200 to 300 million that are on wireless phones, for them to be able to interact across those networks for new services coming out from new customers. These new opportunities that come from this burgeoning demand, the new technology, and these new networks and networks of networks that are coming into place offer even more fertile ground for fertile minds and new inventions. And so I'd like to conclude by again thanking the minds that are here today and for your many contributions, certainly the inventions that sparked creation of revenues and change in the marketplace. I'd like to thank your guests, your family, who are here with you, whose different contributions have also made a difference there. And I'd like to encourage you to even step up the pace on what is already extraordinary accomplishment. That even as the world becomes filled with more opportunities, it becomes more and more competitive. And in many ways, we need both the brain and the brawn. The brain that comes with these new ideas and the new inventions, and the brawn that it takes to really speed these many new inventions to the marketplace, for Lucent to continue to enjoy success, and for me to have opportunities like this to spend a couple of hours with such exceptional people who are making such a difference in Lucent Technologies. Thank you very much.
Thanks, Dan. Thank you. Thanks very much, Dan. I think you did miss out one of the monthly events. It is also Better Sleep Month in May as well, so we'll work on that later, I guess, after the wine this evening. What we'll do now is move to the presentation proper. We'll start with the 1999 Lucent Technologies Patent Recognition Awards. And at this time, to handle that, I would like to introduce Mike Green. Mike is the Chief Operating Officer of the Intellectual Property business, who will do the honors for the rest of this afternoon. Mike, if you'd like to come up.
Thank you, John. I'm delighted to be here this afternoon to honor our inventors and our patent attorneys. As we announce the name of the award recipients, a short video discussing the invention will be played. We will then call the inventors and patent attorneys up to the stage to receive their awards and to be photographed. Our first group of honorees are being recognized for a patent that benefits the Switching and Access Systems group. The honorees are William Jones, Wayne Calbo, Eric Larson, and Elizabeth Mazer. Their invention is entitled Enhanced Privacy Feature for Telephone Systems.
There have been many changes in telephone service since the days of POTS, or plain old telephone service. In those days, one of the only enhancements available was an unlisted number for people who wanted privacy. Today, there are many service features available. The most popular, Caller ID, shows the telephone number of the caller on a display. This allows the subscriber to answer a call or choose to ignore it. If it is not answered, the number is stored for recall later, or the call can be sent to a system that records a message from the caller. Callers who want privacy can subscribe to a service that prevents their number from being displayed on a phone that has caller ID. This feature can be set for all calls or turned on as needed. These two privacy features conflict with each other when one subscriber wants to see an incoming call number, while the other does not wish to have their number displayed. This invention resolves the conflict with a service that ensures a caller ID subscriber receives only identified calls. A private number call to a subscriber who has this new feature is automatically switched to a recording.
We're sorry. The person you are calling does not wish to talk with callers who block their number.
If the caller disables the privacy feature, the call goes through and their number is displayed. The patent also covers a service that allows law enforcement agencies to obtain the caller's number even when the caller has invoked privacy. This invention protects telephone customers from harassing and unwanted calls, while it also safeguards the privacy of customers who do not want their telephone number identified. Innovation, the key to supplying feature-rich products to our customers.
Please welcome William Jones, Wayne Calbo, Eric Larson, Elizabeth Mazer, and the patent attorney who wrote the patent, Werner Ulrich. Werner is a Lucent retiree residing in Illinois who continues to write patent applications for Lucent. Our next patent recognizes a group of inventors for their patent that benefits the data networking group. The honorees are Rolf Berkey, Robert Deonda, Vikram Punj, Ronald Spanky, and Nancy Stevens. Their invention is entitled Bandwidth and Congestion Management in Accessing Broadband ISDN Networks.
The tremendous demand for high-capacity transmission facilities over broadband networks can lead to system congestion. Two techniques used to control network congestion were the allocation of fixed channels and the use of signals to stop or start transmissions. Although both reduced congestion, neither of these provided efficient traffic flow. One transmission protocol used by these networks is asynchronous transfer mode, or ATM. With ATM, data is transmitted by fixed-length cells over uniquely identified virtual channels that are created only when data needs to be sent. These data cells do not flow in a continuous stream, but in bursts, with space between the transmitted cells. Because virtual channels exist only when data is transmitted, their bandwidth can be allocated to other channels when data cells are not being transmitted. This feature makes ATM an efficient method for transmitting data. However, it is possible that the peak bandwidth requirement of many terminals transmitting simultaneously can overload a network. Another problem in these networks is maintaining service levels specified by customers. Some subscribe to priority services that ensure a high transmission rate, while others will accept a lower variable rate. When a data terminal requests a channel, negotiation between the terminal and the network establishes the transmission rate and other control parameters. The network monitors these controls to assure that the bandwidth required by the subscriber is available and that the agreed-to controls are not exceeded. This invention describes a system that provides a significant improvement in network traffic flow. The system is based on the ability of a switch to detect an impending system overload and to respond by sending slowdown messages. One method is to monitor a buffer that receives data from the transmitting terminals. This buffer can be thought of as a leaky bucket with data flowing in and out. If the input rate exceeds the output rate, the buffer stores the incoming data cells. When a buffer reaches a predetermined parameter, slowdown messages are sent to data terminals that can respond to these messages. The terminals are selected based on the controls agreed to during the setup of the virtual channels. The invention provides a fast, efficient way to control traffic flow in ATM and frame relay networks. Lucent Innovations, the key to successful, efficient communication technology.
Please welcome Robert Deonda, Vikram Panj, Ronald Spanky, Nancy Stevens. Unfortunately, Rolf Berkey had a death in the family and cannot be with us today. Robert Deonda will accept the award on his behalf, and the patent attorney who wrote the patent, Werner Ulrich, again. Next, we are recognizing Mark Strauss for work done in the area of microelectronics, for his invention, which is entitled Protection of IGFET Integrated Circuits from Electrostatic Discharge.
The insulated gate field effect transistor, or IGFET, is part of a family of semiconductor devices more commonly known as MOSFETs. MOSFETs, or metal oxide semiconductor field effect transistors, are small, inexpensive, high-speed devices that use very little power. These devices are the most common semiconductors in integrated circuits and can be found in almost all electronic applications. Static RAM, or SRAM, and dynamic RAM, or DRAM memory chips in computers are almost exclusively made with MOSFETs. MOSFETs are particularly vulnerable to electrostatic discharge, or ESD, which is commonly called static electricity. With input voltage limits of 10 to 100 volts, a MOSFET can be easily destroyed during normal handling. Just walking on a rug can store an electrostatic charge of more than 2,000 volts on a person's body. There are numerous methods used to protect a MOSFET from ESD damage. One common technique is to use a large metal gate field effect transistor connected as a diode. When ESD occurs, the metal gate field effect transistor acts as a protective device to pass the ESD to ground. Although this technique is effective, it has some potential defects. A high voltage on the metal gate induces a narrow channel in the transistor formed by the drain, substrate, and the source region. Current conduction is limited to this narrow channel. If the current generated by the ESD is high enough, the metal may spike through to the substrate region, causing a failure. Even if the device does not fail immediately, hot spots may develop, degrading the device and eventually causing a failure. This invention describes a better method for protecting MOSFETs from ESD and simplifying the manufacturing process. The new device is made without the metal gate, and the shape of the drain and source has been changed to provide a large lateral surface area. In this new configuration, ESD causes a reverse current to flow between the drain and the substrate. The resulting voltage allows current flow between the base and the source. This configuration forms a transistor with a very wide conduction channel. Removing the metal gate of the protecting FET and changing the shape of the drain and source permits very high current flow that results in superior protection. Another advantage of this MOSFET is that its high current capability allows packing more devices into a given area. Innovation, the key to successful and reliable semiconductor products.
Please welcome Mark Strauss and the patent attorney who wrote the patent, James Fox. Jim supports the microelectronics patenting in Allentown. The fourth group of honorees is being recognized for their patent that benefits the Network Products Group. The honorees are Arthur Hart, Richard Huff, and Kenneth Walker. Their invention is entitled Method of Making a Fiber Having Low Polarization Mode Dispersion Due to a Permanent Spin.
Single-mode optical fiber is used in 90% of all installations, including long-distance, undersea, and cable TV applications. The manufacturing process starts with a glass preform made of two different types of glass, an inner core and an outer cylinder. The preform is slowly lowered into the furnace to form a thin thread as the tip of the glass melts. As it leaves the furnace, the thread is measured to ensure correct dimensions and then given a protective coating. The coated fiber is cured with ultraviolet light, pulled under a guide roller by a capstan, and wound on spools that can hold about 50 miles of optical fiber. Single-mode fiber has one serious problem: polarization mode dispersion, or PMD. PMD occurs when the signal-carrying light breaks up into two components that do not travel at the same speed. As a result, the amount of information the fiber can carry is greatly reduced. This effect is particularly serious in high bit rate and analog systems, such as cable TV. The problem can be solved by putting a spin on the fiber during manufacturing. The spin reduces the loss of capacity by evening out PMD. A minimum of 4 spins per meter is required to have an effect. The greater the spin, the greater the reduction of PMD. However, applying a rapid spin to optical fiber can result in other types of distortion, such as thinning, and producing a fiber that is not circular. In addition, the rotational speed needed to create the required spin is about 6,000 revolutions per minute, which is not practical in commercial fiber production. Previous methods were useful only in low-speed production. The process described in this invention replaces the first guide roller with a roller that oscillates, causing the fiber to roll toward the edge of the displaced roller. The roll is transmitted along the fiber up to the point where the glass thread leaves the furnace. Because the glass is still fluid at this point, the rolling motion impresses an alternating clockwise and counterclockwise permanent spin into the glass. This method can impress in excess of 20 spins per meter. The alternating spin reduces polarization mode dispersion to lower levels than we can get with spin in only one direction. This invention is currently used to produce Lucent's single-mode optical fiber, an innovative optical fiber with barely measurable PMD and a bandwidth of 40 gigahertz, making it the fiber of choice.
It is my pleasure to introduce Arthur Hart, Richard Huff, Kenneth Walker, and the patent attorney who wrote the patent, Eugene Packer. Gene is at Murray Hill at the moment supporting research patents, including the optical fiber department. Our next patent recognizes a group of inventors for their patent that benefits the business communication systems. The honorees are Peter Costello, Lawrence Fawcett, Michael Lane, Terrence Quinn, and Nicholas Smith. Their invention is entitled ACD Management Information System.
An automatic call distribution system, or ACD, is a key element in the management of a customer service operation where agents are answering inquiries or providing information about a company or its products. To supervise such a system, managers require information about the type and volume of telephone traffic, hold time, call abandonment, and the performance of the agents. This information is continuously updated to provide a real-time display of system conditions, allowing a supervisor to reconfigure the system in response to current demands and traffic. Managers of call centers have the additional challenge of keeping track of agents because agents often handle a variety of tasks other than handling incoming service calls. They may be required to handle walk-in business, make follow-up calls, or spend time on other business-related activities. This invention provides a real-time display of call traffic and agent activity data. The manager can see and change the assigned function and status of all telephone lines, the number of lines, and the identity of agents assigned to each function, triggers or exceptions that identify problem areas, the identity and job assignments of agents doing tasks other than handling incoming service calls, and statistical agent and traffic information that enables a manager to anticipate system loading and allocate resources accordingly. In addition, a manager can monitor call volume, type of call, hold time, and call abandonment, and use this information to reconfigure the facility to maximize agent productivity. For example, the number of telephones assigned to each function can be changed to redistribute the workload. The effect of any change is seen immediately. The data required by a manager must be displayed in a way that facilitates informed decisions about the system. One feature of this invention is the novel display, which is updated to provide real-time data. The well-organized display is divided into several readily identifiable areas. Because some types of information are needed more quickly than others, the manager can set the update frequency of each section. This feature-rich ACD system provides an easy-to-use, real-time management tool that helps businesses meet the needs of their customers. Just one more example of a Lucent innovation that helps our customers succeed.
Please welcome Peter Costello, Lawrence Fawcett, Michael Lane, Terrence Quinn, Nicholas Smith, and the patent attorney who wrote the patent, David Tannenbaum. Our next patent recognizes a group of inventors for their patent that benefits the Octel Messaging Division of Business Communication Systems. The honorees are Gary Kepley, John Lothrop, and Albert Mizrahi. Their invention is entitled Message Service System Network.
The rapid pace of today's business often means that people are not available to answer their phones. A messaging system that includes voicemail is a critical part of any efficient office. In earlier voicemail systems, an analog voice identification of the caller's name and telephone number was attached to the voice message as a header, digitized and stored in the mail system memory. When sent, the digitized message was converted into an analog signal and transmitted over telephone lines to the recipient system. There, the message was again digitized and stored in memory. When the recipient retrieved the message, it was converted to an analog voice message together with the header information. There are three serious problems with this type of messaging system. Each time the message is converted from analog to digital, the voice quality is degraded.
I am now working on keeping track of diversity training for our entire group, and I need your help.
Another problem is the high cost of transmitting a voicemail message. Sending these messages over telephone lines requires significant transmission capacity, which can result in high cost and possible delay. To reduce the cost and the load on voicemail systems, the header is often dropped. This invention solves the three problems of poor voice quality, high transmission costs, and incomplete header information. The new message system can transmit high-quality voice messages with complete header information at high speeds. The sender generates a voicemail message and designates one or more recipients and a delivery time. The message is digitized and compressed, and the header is appended as a text file. The resulting file is formatted and sent as a data file to the recipient's mail server using high-speed computer-to-computer transfer. It is automatically checked for data integrity to preserve the quality of the voicemail message. When the recipient checks for voicemail messages, this system displays a list of message senders and their telephone numbers. The list can be viewed on the recipient's telephone display or integrated with email. Selecting any of the messages restores the digitally stored voicemail to its analog form so that the recipient can hear the message.
Follow up on our conversation from last week, all right? So give me a call back. Thanks. Bye.
This invention is another example of a Lucent innovation that provides faster and better communications.
Due to business needs, Albert Mizrahi cannot be with us tonight. However, the rest of the team is here. It is my pleasure to introduce Gary Kepley, John Lothrop, and the patent attorney who wrote the patent, John Moran. John is located in our Denver, Colorado office and supports voice messaging patents. We now have a special patent to recognize. Although this patent has expired, it is the basis for the fundamental science of spawning new materials developed at Bell Laboratories. The honorees are Albert Ballman, Robert Laudis, and David Rudd. Their invention is entitled Synthetic Quartz Growth.
Quartz, a form of silicon dioxide, is found abundantly in nature. When it is cut into crystals that have parallel faces, it has properties that make it valuable in circuits. Quartz crystals are used to provide accurate frequency in telephony equipment, radio transmitters, and in computers. Chances are that you have a quartz crystal in your watch to ensure the correct time. While quartz is plentiful, the high-grade quartz needed in electronic circuitry is much more difficult to find. Various techniques have been investigated to grow high-grade quartz crystals synthetically. One technique, hydrothermal growth, uses a container called a bomb that can withstand the high temperature and pressure required by the process. Bombs vary in size depending on the desired quantity and size of crystal to be grown. The bomb is divided into two sections separated by a perforated baffle. One or more high-quality quartz crystals suspended in the upper part of the chamber act as a seed for crystal growth. During the hydrothermal growth process, quartz is dissolved in a solution of sodium and lithium salts in the lower section of the bomb. Under these conditions, the solution expands to fill the entire chamber. Because the temperature of the upper section is slightly cooler than the nutrient solution of quartz due to the baffle, quartz begins to deposit on the seed crystal. The deposited quartz has the same orientation and characteristics as the seed. However, at high growth rates, imperfections occur, limiting the amount of quartz suitable for electronic circuits. This invention improved the way hydrothermal synthetic quartz and other crystals are grown. The inventors demonstrated that lithium nitrite and lithium nitrate were superior to other lithium salts and that the use of specific sodium salts has an effect on the rate and quality of crystal growth. They also showed the effects of temperature and pressure on crystal growth rate and quality, and defined the equipment and its use. Using the techniques identified in the patent, the inventors grew synthetic quartz crystals that had a significant increase in quality over crystals grown with previous methods. The growth rate of these superior crystals is more than an inch in less than 10 days. This Bell Labs innovation was fundamental to high-quality synthetic crystal growth. After 3 decades, the basic concepts are still being used.
It is my pleasure to introduce Albert Ballman, David Rudd, and accepting on behalf of Robert Laudis is his wife, Joyce Laudis, and the patent attorney who wrote the patent, Peter Wild. Peter has retired to Virginia and is now writing patent applications, including some for Lucent. This concludes our awards ceremony. Please join me in one more round of applause for all of our inventors and patent attorneys honored today. I would like to thank Dan Stanzione and John Dixon for their support this afternoon. I'd also like to recognize the people who organized today's event. They are Carla Calhoun, Mark Dellinger, Yelena Elkin, Tammy Hanna, Ellen Hurley, Jenny Mikolacek, Brian Prather, Ted Rayfield, Adina Rudder, Francis Rushford, John Simon, and Rhoda Yaker. Thank you all for joining us this afternoon to honor this illustrious group of inventors and patent attorneys. I hope you enjoy the rest of the day and have a safe trip home. Thank you. Thank you.